Okay, we've got this car with an initial velocity of 5 miles per hour, and he accelerates at the rate of 2.4 t miles per hour per second for 8 seconds. How fast is the car going when 8 seconds are up? Well, rewind back to what we talked about in the previous couple of examples. If we integrate velocity, we get position. If we integrate acceleration, we get velocity. So to figure out what the velocity is, we're going to take that initial velocity, okay, so I'm going to call it v naught, plus the integral of the acceleration function. It's not hard. We don't, and we may need to know where we start and stop. We might not. It's not going to change a whole lot our problem. It just gives us something to work with, like an initial value. So if I want to know how fast the car is going when 8 seconds are up, I'm going to take that initial velocity v. So my velocity is going to be 5, because that's where I started, plus the integral of 2.4 t dt, and I'm going to evaluate that from 0 to 8. Because I assume we started 0, that's when we have to start our clock, okay? So what is this going to look like? This is going to look like 5 plus 2.4 t squared divided by 2, and we're going to evaluate that from 0 to 8. And so what would that be when I punch that in? 2.4, that's 1.2, right? So 5 plus 1.2 times 64. 5 plus let's see, we're going over the 8 seconds, right? So when I punch this in to my handy dandy calculator, I get 81.8, and then this would be miles per hour, because that was the units that we were talking about right there. Okay, and so here we go. And remember too, when you have 0 into your equation, that just makes a 0. For the part that we integrated. So for this part right here is where we're going to evaluate from 0 to 8. Well, if I put 0 in the numerator, 2.4 times 0 is 0, divided by 2 is 0. So it's just going to be 5 plus 2.4 divided by 2 times 8 squared. All right? Not a super complicated deal. Now, the next question, how far did the car travel during those 8 seconds? Well, that now is going to be position. And remember that position is equal to that initial velocity, or our initial position. So let's call it S0, which in this case we weren't given an initial position, plus the integral of the velocity. Remember, if you integrate velocity, you get position. So my velocity, when I integrate this, I've got to figure out, okay, what am I actually working with here? Well, my velocity guy is right here. So I could say that my velocity equation, v of t, is going to be 1.2 t squared, okay? And so what do I want to do? How far did the car travel during that time? Well, remember, we started off going 5 miles an hour. So whatever we do, we're going to have to add it to that, okay?